All right, thanks for the patience. All right, let's get it started. Thanks everyone for joining today. Our today's presentation is focused on software-defined wide area network, or SD-WAN. And this is one of our monthly technical webinars. Today we will look how we are helping how VMware is helping our healthcare customers in enhancing their experience and patient engagement by improving wide area network services using NSX SD-WAN by Velocloud. Just to introduce myself, I am your core solutions engineer based out of Chicago. I'm focused on healthcare customers only. And today's webinar will be presented by Jason Marcassano. And Jason is our senior systems engineer from our network and security business unit, which includes SD-WAN. And we also have Sean Pelley. He's our territory manager from our NSX SD-WAN by Velocloud group. Jason, if you forward next slide. Yep. In today's webinar, we will we will look at the challenges faced by our healthcare customers when it comes to WAN services. Then we will go through the technical description of our NSX SD-WAN by Velocloud, and then how SD-WAN by Velocloud is helping our customers meeting their challenges. Then we will look at NSX SD-WAN case studies and some of the examples from our live customers who are using and taking benefits out of it. Finally, we will look at some of the differentiators of NSX SD-WAN by Velocloud, because there are a lot of vendors who are providing similar or who are in the SD-WAN sector. So I will let Jason kick it off from there, and then we will go from there. Thank you.
All right. Well, thank you. Thank you for the introduction, Adam. And just a quick mic check. Can you guys hear me okay?
Yeah,
yes, Jason, I can.
Excellent. Great. So yeah, welcome everyone to the call. Thanks for taking some time this afternoon to discuss and learn our SD-WAN solution by Velo. Again, my name is Jason Marcassano. I'm a senior systems engineer here with VMware in the networking security business unit. And yeah, let's talk a little bit about SD-WAN, but let's start with some of the challenges that we're facing and you know, why we at VMware decided this would be a great solution as part of the NSX portfolio of tools, you know, for you guys to utilize in your environments. So healthcare and IT, what are the challenges that we're facing as part of this? Well, the applications that we're having to support for our healthcare environments are becoming more and more dynamic, for lack of a better term, right? Pieces are being hosted not just in our data center, but also in the cloud. You know, the software as a service is getting spread out, and how we need to get to those applications and present them to our clinicians and doctors, et cetera, is becoming more and more difficult as the application gets spread out across different data centers that are in and out of our control. You know, the other challenges that we're facing is you know, VDI is a giant portion of how EMRs are being presented to hospitals today, and you know, WAN connectivity can be a little sketchy at times, and so how can we improve that connectivity to that VDI session to you know, provide the best experience that our clinicians need to access the EMR. Also, you know, facing some challenges our customers are seeing with, you know, real-time applications. You know, and I'm not just talking voice here, right? Voice is the obvious one, but you know, VoIP type calls obviously need real-time delivery and are very tolerant to you know, WAN dropouts, et cetera. But also, you know, video is becoming more and more prevalent. You know, remote doctor type of scenarios, remote nursing type scenarios. You know, as our patients are being treated at different locations within our healthcare environment, we need to provide you know, the phone, voice, and video in a you know, really reliable fashion, no matter what the connectivity is. And then again, you know, as that application gets spread out, mobile devices are becoming prevalent as well, and treating those mobile devices, whether they're ours to control as part of IT, or maybe they're devices that the patients are bringing in, and we're presenting hospital type EMR feature functionality through that application to that untrusted devices. How do we bring those type of devices into our data center securely? Again, I don't know, raise a hands of the attendees here. Anybody seeing these type of challenges today? Just hit your hands up if some of this sounds like an issue that you guys are. Yep, several hands popping up. I got one there, but so I know one of you is listening. There we go. There's several. So yeah, these are the big challenges we're facing, and so we want to get this under control, right? The WAN as part of this is becoming increasingly complex, right? Again, the application access is being spread out all over the place. It's not just at the hospital where our servers are, but it's the data center, it's the branch offices, it's the remote clinics, it's the doctor's offices. Heck, it may even be somebody's house, right, as they're accessing their data through the remote mobile applications. And again, where is that data being hosted? It's not just the data center, but it's also in the cloud, AWS, GCP, Azure, and then there are pieces that are SaaS type offerings, Office 365 type applications and Dropbox type applications at your Clinicians. I mean, really, this type of spaghetti, and this is really, when I was running my WAN environment when I was in IT, this is what the world's becoming, and we're really losing control, visibility, cost is getting out of hand. Security is hard to manage as these links get spread out all over the place, because every type of link needs a different type of security policy type management, and then provisioning times just get painful, right? The business wants to bring up a new clinic. We want to bring it up fast. How do we do that, right? And so, we've lost control. We're losing visibility, and it's just really becoming a headache. And so what we're really looking at is, bringing SD-WAN to the table to help mitigate these type of solutions, and really bring high quality healthcare to the remote sites that need access to the EMR. And so with that, and I'm going to skip real quick because I want to get to the meat and potatoes of the solution here. Again, legacy networks today, MPLS, direct connectivity, too expensive. Deployments take months. How can we solve that, right? And I believe really strongly that this is where an SD-WAN hybrid solution really comes in. So with that, I'm gonna hand this over to Sean. And Sean, I'll let you take over at this point and present the solution to the crowd.
Sounds good. Thank you very much, Jason. And along those lines, I just wanted to reiterate, these problems, while we're speaking specifically to healthcare, of course, are shared amongst the wide variety of industries. Healthcare does certainly have some specific needs, but what we're really talking about is kind of a shift, an evolution in wide area network capabilities based on the lack of innovation that's happened over the past 30 years. So two words stand out to me when we look at the challenges of legacy networks. One is brittle in terms of architecture and very static, right? So the antithesis of that, and what we're bringing with software-defined WAN, is a much more agile network that can accommodate the shifts that are happening for us in our customers' practices, whether it's IoT, whether it's different medical devices that are part of that IoT world, whether it's accommodating a new direction for the business, right? Doing community networking for physician offices, hosting of EMR, EHR, or whether it's a new acquisition of urgent care clinics that you need to fold into your network. The ability to be more agile, for the network not to be a stumbling block, for the network not to be the delay in bringing on a new facility into the network, right? And then the flexibility to grow as you decide to allow for local access to cloud-hosted software as a service type applications, what have you. So what we're really looking to deliver, and what you'll see from the solution, is the ability to become more agile and for the network to become more elastic to meet business requirements. Okay, and along with that will come all of the great cost savings, the new capability sets, the simplicity in operations, right? The ability to go home at 5 or 6 p.m. instead of 2 in the morning because of a circuit outage. All of that comes with it. So wanted to hit on the high points. Okay, yeah, we can move along, Jason, thank you. And we'll jump straight to these components, which I like to share are what I like to say kind of table stakes with software-defined WAN. So there's 3 things that software-defined WAN should deliver to you, regardless of what direction you head. One is going to be centralized management, right? So no longer do we have to struggle with the days of logging into a device, configuring it with all this, archaic jargon called CLI, moving on to the next device, configuring it, and then hoping our devices talk to each other. Right now we have this very modern way of intuitively constructing our network, viewing its performance, setting alerts, and sharing information within the organization. So centralized management is one. Number 2 is automated secure connectivity for any transport links that historically have been non-private or non-MPLS or point-to-point. Right, we've had to build these static tunnels using some kind of VPN structure, whether it be a VPN concentrator or firewall, whatever it is. Those days of managing a VPN system should go away, right? SD-WAN delivers automated secure connectivity based on the parameters you set. Is it hub and spoke? Is it fully meshed? Are there some sites that can talk to each other but others that can't? That is very simple and intuitive to set. Automated secure connectivity, dynamic. Third and finally, the most popular, I'd say, among the SD-WAN perks is active WAN link utilization. It's a long way of saying I've got 2 links, I get to use them at the same time, right? Should have been this way. Really, when you look back on it, I've been doing SD-WAN for 5 years now, and it should have always been this way. Why do I have to have a primary link and a backup link that I'm paying for but not able to use, right? I want to be able to intelligently use the transport, the connectivity, the capacity, really, that I have available to me at that site in an intelligent way. And I want to be able to determine what traffic goes where, or let the system decide based on performance where it should go. Okay, so I get to decide now whether I'm going to have 3 carrier diverse internet links or whether I'm going to keep my MPLS and augment it with DSL, broadband, LTE, microwave, anything I want, right? I can bring to bear and use them in an active fashion. I do like to say and share that it's everything else that matters. So we're going to show you how these 3 things are easily accomplished, how they're done intelligently and effectively, and how they're unique from the rest of these vendors in the marketplace. Right? So that's where the meat and potatoes are. How do we accomplish these things? How's it done? And what's special about it? All right, so what we're looking at here is a very simple WAN diagram. There's a lot to talk about, however, a lot of interesting things here. There are 3 components to the VMware SD-WAN solution by Velocloud, and they are listed on the left. The first is the orchestrator, and that orchestrator is our centralized management tool, right? So we talked about a centralized management plane, and that's what the orchestrator is. It is hosted by VMware for customers. It's provisioned for you. Every single customer gets their instance of an orchestrator, and it's where you can go create a new site in your SD-WAN network. It's where you can go set intuitive business level policy for how your network should behave, how your applications are prioritized based on security, performance, compliance, etc. You can view monitoring and analytics about how the underlay circuits are performing, how the applications are performing. At a particular site, what are my top talkers? If I get an alert that I'm seeing congestion, why? What's the congestion for? What's consuming all of the capacity? Is it a specific user? Is it a process? Is it a particular application? Do I want to implement a policy that shapes that traffic or rate limits or polices a particular application? You can do that on the fly in the orchestrator, right? Now this orchestrator is not your traditional networking archaic screen. It is all HTML5. It's very intuitive. It's check the box, drag, drop, right? And it's all API driven. So while it's very intuitive from a GUI perspective, if I wanted to take that next step, and I was very forward leaning and I wanted to script, automate, or integrate with the API via something like a Terraform or some of these other DevOps tools, I could absolutely do that, right? Because every command in that orchestrator is an API call, right? So it integrates very nicely with a variety of tools that you may want to adopt. If you don't do that, no problem. It's just a much more intelligent way to manage your network today. Okay, we'll move on. The second component is the cloud gateway. It's represented by those beautiful little blue clouds, and their function is to be a distributed control plane. Okay, so that provides a lot of automation as well. It will auto-learn advertised routes from sites in your network, so that'll auto-learn a lot of the reachability within the network. And these, again, much like the orchestrator, are out there in the world, available to customers, maintained, supported, provisioned by VMware for our customers. And each site actually will connect to 3 gateways. So there's very significant resiliency and redundancy built into the system. There's going to be a primary, a secondary, and a master gateway assigned. Now, while those, the primary function of those gateways are to act as a distributed control plane, they also optionally participate as a secure endpoint on the internet for customers. So if you want to, this is not mandatory by any means, but if you want to connect to a gateway because you have an application or several applications that are important to your organization, but yet they're destined for somewhere outside of your network, right? And we're talking about cloud and SaaS again. Well, you can use a gateway to terminate that secure connection and do all of the wonderful work that we do to prioritize, to steer, and to remediate against impairments for that traffic. So effectively, if you're going to connect to a gateway, we can insulate you from the degradation of impairments, right? We're talking latency, packet loss, jitter, so on, between your edge location, your remote site, and a gateway. These gateways live at tier 1 data centers, so they're internet peering points, and once you get to them, you're on a very high performance fiber loop from that provider. And there's various providers available because they're on the backbone of the internet. Oftentimes the gateways also exist at the same facility that application or service is hosted from, right? We're talking about all the Equinix data centers, AWS data centers, Office 365 data centers. That's where the VMware gateways exist. So they play a critical role. They're out there available to all of our customers. They're multi-tenant. Their core function is a distributed control plane, but they optionally are available if you wish to prioritize and promote the performance of cloud and SaaS-based traffic. Okay. Huge differentiator. No other vendor in the market has these. Provide a tremendous benefit to many clients. Okay, so that's the second component, the cloud gateway. Nothing for you to install. It's all done by VMware out there in the world for you. The third and final component is probably what we all recognize most about deploying a wide area network. It's the virtual machine or the physical machine that goes at the edge of our network, can either coexist with your legacy router or oftentimes replace it, depending on what it's doing, right? So if that router is just terminating WAN connections and routing traffic, we can absolutely replace it. If that legacy router is doing say a voice gateway, it's doing SRST, or is terminating a TDM circuit with serial connection, that's a reason to keep it in place and use it as a media converter. Maybe even use it for resiliency and high availability. But depending on what you're doing, we can coexist or replace it. The edge device comes in various sizes based on throughput. You can think of it as the data plane, right? Because that's what it is. It is a fast packet forwarder. It's got all of its configuration and its policies cached because it's receiving them from the orchestrator. in real time. If you make a policy change, it gets pushed out based on which edge locations are part of that profile that you want it to change. And it's gonna do the bidding of the policy and configuration dictated from the orchestrator. Okay. So those are the three components of the Velocloud, the VMware NSX by Velocloud system. The only component you would receive and really have to install is the edge. And you can take at your data center, you could take an edge device of appropriate throughput and simply promote it to be what we call a hub device. So you identify which locations are your data center or data centers. And if there's a prioritization within there, you can quickly dictate that. Where it gets really interesting, now that we know what the components are, is how we decide to manage traffic, right? What do we do with the traffic we see? How are policies enforced, right? What's important to us? And that is represented by those very interesting little tunnels, and you see below it says dynamic multipath optimization. This, again, is a very unique and hugely differentiated way that we steer traffic. And it's based on what you dictate in the orchestrator, but it's the ability to steer that traffic on a per packet basis, right? So as we measure in real time the performance of any given link, if you make it available to the system to do that steering job, we will steer based on what kind of application it is, its priority, the conditions of the available WAN links. And if we can't steer around a condition that may impair its performance, then we can even enact a process that we call remediation. And we're going to dive into that a little later, but I wanted to give you some insight into the intelligence of traffic steering. Because if you do have more than one WAN link available at a site, I want to make it clear that it's a whole lot better than just load balancing across those links. There's a lot of intelligence in the system if you allow it to make its steering decisions that will benefit the performance, regardless of whether those applications are hosted in your data center or they're hosted by a third party as a SaaS cloud application. Could be hosted Epic, Cerner, etc. Office 365. It will receive the same benefit of dynamic multipath optimization.
Hey, and Sean, can I just quickly put you on the spot here? How hard is it to turn on that steering? I mean, are we going into a command line and are we tweaking BGP timers and stuff like that, or is it a little bit easier than that?
Yeah, it's a great question. For all the benefit that you receive, it's actually incredibly simple to activate. It literally is a single check in the policy for an application for you to decide whether it's high priority and whether it should be multi-pathed. That's the key word in the orchestrator. You select multi-path and high priority, it will get all of the wonderful steering associated with dynamic multipath optimization. So again, doing that between sites, between site and data center, or between site and gateway is going to be available. There's no static thresholds to set. There's none of that. It's all automated for you.
Yeah, I think that's great. I mean, that really, what I think that really shows is that these benefits that we're discussing are just built in and they're innate to the solution versus the traditional way of tweaking timers and manipulating things that you're kind of done doing unnatural things to the network to make it do what you want it to do. These are just natural in the SD-WAN world, and then really bring benefits to you right away.
Yeah, that's a great point. And it all comes back to simplifying operations, right? We don't want a trade-off of getting a bunch of capabilities if it makes our lives difficult, our environment complex, difficult to support, and certainly difficult to configure. All of that is our end goal is to do both, to add capabilities and simplify, and that's really a hallmark of SD-WAN. One thing I didn't point out that I want to make clear is, again, the transport, the WAN circuits that you choose to use in between us, right, between these edges and these data centers or the cloud, these are now become fairly agnostic. You have the freedom to choose whether I'm going to select multiple broadband or internet links at a site, whether I want to combine private networking with public internet, whether I want to use LTE, DSL, microwave, all of these gray clouds in between our locations now are basically virtualized, right? They become just sources of transport that we mix and match based on what we think is best for that site, based on performance, based on capacity, and yes, based on price, right? So we're gonna be looking at it from a different lens now that this overlay transport or this overlay network has been provided to us, right? So every tunnel is 256 AES encrypted. I dictate who can talk to what and where and why. And so the security concerns are alleviated, the performance concerns are alleviated. I get to focus on what's best for my site: capacity, performance, vendor availability, right? I want to be a lot more resilient and agile in how I select my transport. So very different than the previous few decades in networking and selection of transport. Okay, so moving along, there's, if we're classified, now that we see the components, we see what the capabilities are and what we're able to do, what's the value? How does it impact me, right? Number one is going to be branch transformation, excuse me. I am looking to lower costs, but I don't want to sacrifice capabilities. So, with this model, I can receive SD-WAN as a subscription. I don't have to make a huge upfront investment in devices. The old way of procuring infrastructure is buying a box of some kind, and I throw down a huge chunk of change, and I hope they don't pull the refresh card on me, next week, next month, next year. I want that to last. Well, the new model now is a subscription. We provide the hardware that's required, and you don't have this big upfront investment, right? It's much more kind of a SaaS model where I'm paying for the value and the licensing that I receive, and the hardware happens to come with it, right? If I choose to upgrade in the future, I'm going to get new hardware. It's going to be swapped out for me. So lowering costs from an infrastructure perspective, lowering costs certainly from a WAN connectivity perspective, if that's important to you. Many organizations, when they first deploy SD-WAN, will choose to simply use the connectivity they have, right? We may not be meeting them at a point where their contract is up. Well, that's fine. You get to plug in that private network and that internet link that was previously a backup, and you get to use them active-active. So my cost per usable megabit per second has come way down, right? Now I have this diversity of using multiple transport types in an active-active way. I'm probably going to see significant savings there as I make adjustments going forward based on what my locations need, right? And then there's, the branch transformation decision making. It has been altered. What do I want to backhaul? Are there applications that I now want to allow to egress locally from my edge location? Maybe I want hosted Epic to egress locally from that site, so it doesn't have to be hairpinned or backhauled to my data center. Maybe it's Office 365, right? These are what we call lovingly sanctioned applications that organizations now understand because they can be identified, because I have a simple policy construct. I can be more nimble or agile in how I allow traffic to traverse my network, right? Does it have to come back to my data center before going to another remote site? No, maybe I'll allow it to go site to site. Maybe I'll allow it to go straight to the internet for cloud and SaaS access. So that branch transformation, how it impacts everything else in that environment, is just amazing to see. You now have all of the restrictions removed. You're in charge, and you can dictate how exactly you want that branch to look and behave and perform. Next is the WAN management. This is really, in the old days we would call operational cost savings or soft cost savings, right? How does this make my life better, right? Again, I want to go home at 5 p.m. to see my kids recital. I don't want to be stuck in the office managing a brownout on one of my WAN links until 2 a.m. So because we have the orchestrator, we have centralized management. It is very intuitive. All of the jargon and the CLI that has had to be learned over years of training and certification is alleviated, right? We can go in and intuitively dictate what's allowed, again, for security requirements, for compliance requirements, and for performance, right? What's important to my applications? How do I want them to behave? How can I promote performance? Either by prioritizing them, shaping other traffic, multi-pathing that traffic, not backhauling it, all kinds of different techniques that we can apply to ensure performance. But beyond that, right, once we dictate policy, I want to trust but verify. I want to look into the system and see how it's behaving. Now that I've instituted these policy changes, show me the performance. Show me the realization in a graphical way of my top applications, my top talkers. What's consuming capacity? What's the utilization like? What's the actual performance of the link? Do I see better latency? Am I avoiding packet loss and jitter, right? Simplified WAN management comes by way of this orchestrator centralized management, and you combine that with the policy construct. It's a really nice living organism that you can interact with. Finally, optimize cloud access. This is going to be dependent on your organization. Have you adopted a lot of cloud and SaaS? This is going to be the best thing since sliced bread for you. If you haven't and you don't, and you're like many organizations, more conservative than traditional enterprise networks are, that's fine as well, right? It's simply allowing, as you grow and as things change and some things move to that arena that was unfamiliar in the past, you are now more elastic, right? The business may decide to transition a part of the business to, say, a hosted voice system, or again, hosted Epic, or it's Office 365 for the physician offices or the clinics that we've just acquired. No problem. My network is able to handle that, right? My policy control allows me to promote performance, to maintain compliance and security, okay? Whether that involves segmentation, I want to segment guest traffic from HIPAA traffic, from PCI traffic, from data or voice. I've got that in my bag, right? That's easy to configure in the orchestrator, something that many of us haven't had in the past, right? I've got this agility to maintain all of those requirements I've had, but now it's point, click, drag, drop in the orchestrator. Okay, so those are the benefits and categorically where they fit. Quick snapshot of some of the screens in the orchestrator. As you can see, it's going to be very familiar, right, to the way we interact with modern services today. You're going to have a dashboard and a map of all the locations in your SD-WAN network, the initial status of them. Are they up, down, offline? Are my tunnels up? Are the standard tunnels that are connected to my hub or my gateways? How are those performing, right? And then I'm going to drill into a particular site, right? We're going to automatically identify the carrier for the circuits that are plugged in. We're going to identify the status and the capacity of the throughput of those links, the initial top talkers, the bandwidth usage by application. And by simply clicking on any one of these components, it'll cross-launch a new, more granular graph or screen to show us more detail about that section we wanted. Maybe it's Spotify. Show me who's using Spotify at my Palo Alto branch, right? I want to see, because it's usually not in the top talkers category, what's going on, right? Right now, I want to see what users are downloading their entire library from Spotify, right? Maybe people get called out on this, but this is going to give you the visibility that most of us have always wanted but never had. Okay, and this is what the monitoring and analytics component of the orchestrator brings for us. This visibility, because once we have visibility, once we have management capability, we can go in and institute policy, right? Maybe we want to shape Spotify. Maybe we want to make YouTube a high priority for my clinics because we're going to use it for training, right? All of that is available to me in the orchestrator. And as you can hopefully see from this very static picture presentation, the way you would interact with it, the simple tabs that are available, is how you want to view your network. And again, there's no CLI in this, okay? This is all HTML5. It's all, every single command, everything you do here is an API command. So if you wanted to script, automate it, you can certainly do that, or simply use it as a GUI as it's presented. Okay, performance. To me, this is the most exciting part of the whole thing, to be honest, because just like you and I, we're users as well, right? And it's important to make sure we have security down and compliance taken care of, but performance is the exciting part, right? This is kind of the cherry on top. And as I mentioned, the process that we provide is called dynamic multipath optimization, and it's really comprised of 3 different things. And the first is continuous monitoring, right? The system not only is going to identify the carrier, it's going to start measuring capacity, but graphically and in real time, it's going to provide continuous monitoring. Every 100 milliseconds, it's going to deliver a result of throughput, latency, packet loss, and jitter, okay? And that information is great to see graphically, and again, provides more monitoring capability than we've had in the past. But when you, truth be told, when you think about it, the real reason we're doing all of this unidirectional monitoring of the underlay performance is to power the next capability, which is dynamic per packet steering, right? In order to steer traffic to deliver the best performance, we need to know what's going on in the links. So we're going to measure it via continuous monitoring, and that will feed the per packet steering engine, right? I like to say it's kind of like if you're going to take a shortcut in your walk to work, you might want to go down this alley, right? Well, what if there's some bad guys in that alley? Well, maybe I'll take the next one. I want to avoid that. It's the same concept. If there's a problem on one of my WAN links, an impairment, whether it be latency, packet loss, jitter, or maybe congestion, well, if there's another lane available to me, another alley to go down, I want to take that one. I want to make it a smooth ride to work, right? So continuous monitoring feeds dynamic per packet steering. We want to avoid impairments wherever possible. And that's important, not only the capability, but it's also very important to let you know that we're a per packet system. So as a packet-based solution, even if there's an active session, for that same session, we can steer packets to an alternate link in real time, right? So just because your call is on a WAN link doesn't mean that that WAN link is going to provide the same conditions for the whole call. Over time, things change, right? These WAN links are living, breathing things, it seems sometimes. And as conditions change, so does the packet steering system. It's going to identify an impairment, steer around it. All the other vendors, our peers in this space, are flow-based solutions. And when they put a flow or a session on a particular WAN link, they're married to it. They can't switch it, right? They're stuck there. And that's a problem, because once things go bad, if you're stuck there, the only thing that can happen is that session gets terminated, right? Somebody hangs up the phone or ends their session, or the WAN link fails. That's the only opportunity they'll have to switch paths. Okay, so far more granular. Finally, the third and final step in this process that we call DMPO, Dynamic Multipath Optimization, is remediation, right? So, you know, common question, Sean, what happens if both my links are bad, right? Or what happens if one link fails and the other one that I'm stuck on is really bad, right? Well, in that circumstance, in that scenario, we have our third and final option available to us. It's remediation. And what we do is it's dynamic. So we can turn on specific remediation techniques to mitigate a specific impairment. We do this only for the high priority applications. And of course, you dictate what's high priority. And we do it dynamically. So these things are not just always on. When we see packet loss on a link and you have voice traversing that link, we can and will turn on forward error correction, right? Proactive packet duplication to mitigate the effects of packet loss and improve the experience of that voice call. If we see jitter, we can turn on jitter buffering. We will for your high priority applications traversing a link with jitter. That means, you know, jitter buffering is basically holding the packets back for a few milliseconds, putting them in the proper order, delivering them to the user, therefore mitigating the effects of jitter. And then finally, for all of our TCP applications, we do employ TCP negative acknowledgement, or TCP NAC. And this helps us maintain high throughput levels for those highly communicative protocols, TCP, and avoid the aggressive back off of TCP when it sees an impairment on the link, right? So you compare a line with TCP negative acknowledgement enabled with that of one that's not, and you're going to see a far higher throughput level out of that same circuit through the technique we call TCP NAC. So, put it together, right? If you're able to do all three of these things very well, continuous monitoring, dynamic per packet steering, and remediation, the net result is what we're looking for. It's a high quality experience for our users across the wide area network, right? And that's why we have a wide area network. Of course, to connect them, that's fundamental, but we want them to have a great experience. This is the automated, intuitive way that Velocloud, entirely unique to us, delivers it to users, right? Again, it's called dynamic multipath optimization. It's available if you click that multipath link via policy and let us do the work. Speaking of policies, very simple. This is a screenshot from the orchestrator of a policy. This is for Epic, right? We've determined that's the application we want to build a policy for. We could build a policy for a group of applications or a particular application, right? We can even implement a policy, a different policy, say for YouTube on our corporate data segment versus the segment that's for guest users, right? We could have a different application-specific policy based on segment. So we can get extremely granular, if you like, as to the attributes. But here we've selected high as the priority for Epic. We've selected that multipath capability. If we chose direct, which is next to multipath, that would mean we're basically split tunneling, sending it to the direct underlay, whether that be private or public transport. We could alternatively internet backhaul it. In terms of link steering, it's set to auto, right? So we don't want to, in this instance, dictate that it's a private network or a public network or any kind of category of transport. We're going to let it auto steer between them. We can do tagging, right? DSCP tagging. We can copy the inner tag. We can change the tag on after it enters our tunnel. We can manipulate that. If you want to keep that DSCP tagging infrastructure you have in place, you're able to do that. If you want to change it or alter it, you can certainly do that as well. NATing is on the fly. Service class, right? If it's a custom application, let's determine whether it should be treated as a real-time, a bulk, or a transactional application. Each of those types of applications have different requirements, different performance impacts from WAN impairments, right? So we want to know how should it be treated. And maybe it's obvious, but I want to make sure it's clear. Out of the box, the solution, the VMware SD-WAN solution, is going to provide over 3,000 applications that are identified, right? So you're not going to have to go in there and configure all these things. There's all these smart defaults in the system for policy, as well as automated application identification. You will likely have some custom applications, and that's where you can create a custom application definition via policy in the orchestrator. So you can see how specific you might be able to get with policy creation. Okay, I've alluded to segmentation a couple of times because for healthcare, it's extremely important. We have, our fair share of compliance requirements to meet, two of those being HIPAA and PCI. And so segmentation from end to end can be very critical and give us further control over traffic. In addition to putting a big black rubber stamp on our auditors to show them that our wide area network is compliant with those requirements from HIPAA and PCI. So at any given location, and this can be driven by profile, right? Maybe our hospitals have a certain profile, but our urgent care clinics have a different profile. Our physician offices, yet again, have a third and different profile. So we can set up segmentation by profile or by specific site. And what we're talking about here is isolating or segmenting that traffic type, right? We're going to put it into effectively its own VRF, right? So very common segments to name, and they're all custom named. Could be guest, PCI, HIPAA, voice, data, right? I think you have up to 64 different segments to select from. Or if you don't want to segment traffic, no problem. You just have one master segment. But this is the ability to completely isolate traffic from your hub or data center all the way out to your remote site and facilitate some of those compliance requirements we're all faced with. For PCI specifically, VMware, Velocloud as part of VMware went out and got our own attestation of compliance. That's a great word, attestation. AOC, and if any of you have been involved in PCI, it's a really hard thing to get, right? We used Coalfire and went through an exhaustive process of attaining our own AOC so that we can provide it to customers. And we have documentation we provide to customers that select this service. If you're under this requirement and you want to, again, put a big rubber stamp on your PCI audit for your wide area network, this will do it for you, right? So it's extensively has been audited internally for us based on the operational model, the hosted services and components, as well as the actual practice of encrypting certain streams, providing segmentation, et cetera, et cetera. Okay, another high value part of the system. I mentioned before, it would be great to get all these capabilities, but I don't want to concede complexity for this control or this set of capabilities. So we've always kept it very simple. In fact, there's a kind of a very aggressive standard that we have to meet with all of our features that are added to the solution. And it has to do with simplicity in deployment and maintaining the system. So this is a really quick example of how you might deploy a new site in your network. And I think many of us can attest that that's been a very complicated process in the past. Well, with the Velocloud SD-WAN solution, it can be as simple as this, where in the orchestrator, right, you've decided to create a new location. Let's say this is a new urgent care clinic for us. It fits that urgent care profile that's set, right? It's a template already built for us in there. So it's going to fall into that category and assume that profile. Going to identify what kind of device I've requested to be sent out. VMware Velocloud will send that device, if you like, straight to that location. You can alternatively have it sent to your office, if you like. But it can get shipped directly to that location. Once it's received and unboxed, you don't necessarily need a network engineer there. It could be the office manager, right? And this is that really aggressive standard that we seek to meet. That office admin or manager can unbox the device itself, can plug in the Ethernet cables, right, to the appropriate ports that you tell them to. The power cable gets plugged in. And then most of our remote locations, the devices will actually emit its own Wi-Fi signal. So it's a wireless AP built in. And all you have to tell that user is, ask them to log on to that wireless network, that SSID, or they can hard cable into the box if they want. Tell them to open their email, right? You've sent them an email. They're going to see it there at the top. Embedded in there is a link. All they have to do is click on that link. And when they do so, it's going to authenticate with the orchestrator, pull down its configuration based on the profile you added it to. And immediately, it's going to become live on your network, right? So regardless of what kind of connectivity you have, it's going to call home to the orchestrator, download its configuration, build the required tunnels to connect to your hub and to the gateways, and it's live. It's now active on your network. And I'm talking about the ability to do this with an LTE USB modem if you want, right? Or that internet link, or that broadband local ISP cable connection you have, or it could be your MPLS. Whatever you have, you get to plug it in and make use of it right now. Right. One of my favorite stories is one of our partners, when Hurricane Harvey blew through Houston, they went down to City Hall and they took one of these Velocloud devices. They plugged in a couple of LTE USB modems, and they immediately provided connectivity, not only to the folks at City Hall, but to citizens, the city of Houston, that were needing access to emergency services. Right, so these plugged this thing into a generator, and they provided internet connectivity, vital internet connectivity, to both City Hall and the citizens that were stuck there. Right, it's an example. If they can do that, I think you're going to see a great simplification and bringing your new office locations online. Whether it's because of an acquisition, a net new office that's being built and stood up, or a pre-existing location that you're simply adding to your SD-WAN fabric. Right? Very straightforward, very easy. Does not require a team of network engineers, weeks to do this. Very quick.
Okay, Sean, real quick. So we got about a 5-minute check left with everybody's time. Is there one more point that you want to hit, or do we want to go over case studies at this point?
Yeah, I think we can jump into case studies.
Okay.
Yeah, so Sabre Healthcare Group is a great example of a customer with a pretty good sized network, right? 120 plus locations. And what they really wanted to do was the whole host of SD-WAN use cases, right? They wanted to increase the capacity of their applications. They were kind of straining under the existing capacity of the private WAN links that they had, and bringing new locations on board was a further headache. So they wanted to streamline that. They wanted to increase the capacity, the elasticity of their wide area network, and that was fundamental. What they got was not only the capacity and the ability to bring on these new locations, but they had this newfound visibility, right? Because you can't manage something if you don't measure it, or you can't measure it. And now with the ability to not only monitor performance, but institute that policy construct based on what they're seeing, they were able to create smart policies that fit their business and that fit the requirements of the end users and of the compliance requirements they were under, right? So what they started to do was add some low-cost internet and broadband type circuits to supplement their private network, and then decide what applications needed to go where, what they wanted to let auto steer and multipath, ultimately to benefit the end users and allow the business to grow at a more rapid pace than was possible before. So before SD-WAN, literally the entire business at Sabre was limited by the network. That's not a good place to be, right? You want to facilitate. You don't want to limit things from a business perspective. So their growth was definitely enhanced by bringing on a more agile SD-WAN solution from VMware. So low T center, low testosterone center, kind of a medium-sized network, 57 locations, and they wanted to increase the performance of access to their EMR system. They were facing some outages, right? Not uncommon, even with private networks and MPLS. Things happen depending on where you are. Rural locations, even in metro areas, it's not a good thing to put a sign on your door saying, "Sorry, office is closed. The internet is down or the network is down." That's a bad reason to have to close an office, right? And they just didn't have the visibility to measure application performance and manage those outages. When they adopted SD-WAN from Velocloud, they had the visibility. They were able to utilize multiple circuits and formats, right? So even if a landline circuit got cut, they could use LTE as a failover. Not just a failover, but a sub-second failover. Phone calls survive. EMR sessions survive, VDI sessions survive, even a link going down hard, right? This is a much more pleasant way to operate a business in the face of those kind of challenges. So long-term projects were more achievable. The ability to future-proof and to maintain uptime and availability was critical. And so this is a really substantive use case where closing an office or not being able to operate the business effectively was challenging because of the network. SD-WAN alleviated those challenges as well. And they use segmentation, and they had all the compliance requirements that most of us do. So.
Hey, Sean.
Yeah.
There's a question in the Q&A. Does Velocloud have any touch points with VRNI, NSX, or VDI?
Yeah, great question. So we see a really obvious pathway to integrate with those solutions within VMware. There's obviously a lot of similarities with VRNI and the capabilities to kind of cross-pollinate information. Of course, with VDI, we identify it as an application, and we can apply the wonderful policy constructs that will promote the performance of it. So there's nothing really special needed for VDI, but you can see where there's natural points of integration. And today, the most obvious that's happening today is the integration of, say, Velocloud is part of the NSX family. So you can map NSX microsegmentation to the end-to-end WAN segmentation present in the SD-WAN solution. That's available today. And as we go forward, these other obvious areas of streamlining are going to be incorporated. But today, VRNI is not integrated with the solution, but that's certainly, we're looking forward to that. Yeah, good question. So we started off by the three kind of table stakes components or capabilities of SD-WAN, starting with centralized management. And hopefully what we've demonstrated is it's not just something you install at your data center and you hope it's able to manage all your devices. It's hosted, right? It's cloud driven, it's all API driven, and it does have that intuitive element. So you can create profiles, you can use intuitive business policy constructs to stay in compliance, to establish performance parameters and security parameters for your network, right? So it's not just centralized management, it's everything else that you care about going into it. For an automated secure connectivity, we use unique keys per tunnel, right? So we don't have, like our other major competitor, a problem of a shared key and any one tunnel being compromised and then making the rest of our network vulnerable, right? So we haven't compromised the integrity of our network because of the automation. The overlay is and likely a whole lot more secure than any VPN system we've had in the past as a legacy network and deployed in many enterprises. So you can have unique keys per tunnel and a dynamic site-to-site tunnel. So we avoid this this resource restriction that is very common in building tunnels across wide area networks. We build tunnels dynamically. So if an office or a clinic needs to talk to another one, we'll dynamically build that tunnel and tear it down when it's not required. So automated secure connectivity, but yet the intelligence that you would expect. And finally, the third and most popular of the SD-WAN use cases is the active WAN link utilization. We talked about the packet versus flow comparison. So what you're going to get is per packet steering, the ability to react to brownout and certainly blackout conditions in a sub-second fashion, keeping phone calls live, EDI sessions live, EMR sessions live, even with severe brownout or blackout conditions. And access to full bandwidth aggregation. So being per packet means that you truly can send large files, whether they be radiology images or what have you, across and take advantage of the full capacity of multiple links instead of just getting steered down one of those. So everything else that matters on these concepts, hopefully we've demonstrated and shown you how we do it in a very unique and intelligent fashion. We encourage you to ask more questions. If this was compelling at all, send those to Adam, to myself, to Jason, and we look forward to doing proof of concepts with as many of you as possible, something we certainly encourage. You can believe what we say, but we'd like to put it in your hands and let you try it out for yourself.
All right, thanks, Sean and Jason. Are there any questions you would like to ask from the participants? You can do that. I mean, we can go a little longer. Meanwhile, Sean or Jason, do you want to show the latest Gartner Magic Quadrant came out just to because it came out like a few days ago, so I wanted to take this opportunity to show that. If not, then we can send that in an email.
Sure. Yeah, I'd be happy to. That came out a couple of days ago. A lot of people rely on Gartner for their information about vendors and different solutions from an infrastructure perspective, and this is that Magic Quadrant that came out. I think I'm sharing it wrong. How's that look? Yeah, and then we see VMware in the top right, Leaders Quadrant. Very proud of that success. Not only the success from an identification from analysts, but the market share reports and the partnerships that we have going forward.
Cool, awesome.
This is available from the VMware website, everybody. If you want to download it and read all the nitty-gritty details, you can go ahead and go to the site and download the full report.
Very cool. Thanks, John and Jason, and thanks for everyone for attending this session. It was recorded, so I will send out the final recording to everyone, and so anyone who missed that, you can forward that to those team members, and they can view it when they have time. Yeah, and then look forward to my next monthly webinar invite. I will be sending it out in a week or so. And thanks again. Thank you, everyone.
Thank you. Take care.